Alright guys, welcome to this page of the notes, and what we're going to do now is exactly what we did before, where we're going to add and subtract rational expressions. But those rational expressions are now going to be polynomials that you may have to factor, or not that you may, that you will have to factor in order to find the LCM. But we practiced that earlier too as well. Here we go. I need to find the LCM of my denominators so that I can make that LCM my common denominator. All right, let's do that. Let's see here. 4w minus 16 will factor into 4 times w minus 4. And 2w minus 8 will factor into 2w minus 4. So there we go. I found my LCM by taking each factor the greatest number of times it appears, which would be 2 times 4 times w minus 4. And that means that I have 8 w minus 4. All right, so my LCM is 8 times the quantity w minus 4. All right, let's rewrite these guys, denominators, in factored form so that I can figure out what they need in order to get them to my LCM. All right, so this is going to be w plus 12 over 4, w minus 4, minus w plus 4 over 2 times w minus 4. Okay, so now that I've written my rational expressions that have polynomials in them in factored form, I need an LCM of 8 w minus 4. Well, the w minus 4 is already there. I just need this 4 to be an 8, which I can do by multiplying top and bottom by 2. W minus 4 is already there. I have a 2. I need it to be an 8. Multiply top and bottom by 4. So what I wind up with is w plus 12 over 4, w minus 4, multiply top and bottom by 2 over 2, w plus 4 over 2, w minus 4, top and bottom by 4. Okay, so what that's going to do is that's going to get me a common denominator that is my LCM. Careful when you're multiplying the tops, because these are binomials, you'll need to distribute through the parentheses, right? Distribute through the parentheses. So here's what I get. I get 2w plus 24 all over 8w minus 4 minus, right, so 2 times w, 2w, 2 times 12, 24. All right, 4 times w is going to be 4w plus 16 all over 8w minus 4. Okay, so now I have my common denominator, which I'll write as my common denominator and subtract the numerators. Careful, the numerators, right, actually here, just let me write it. I'll just write it. So it's going to be 2w plus 24 minus 4w plus 16 all over 8w minus 4. Okay. Now again, there's going to be a ton of steps here that you guys will probably be very comfortable with skipping at some point. I apologize. Let me slide this over so that I've got some space here. And I'll come up here to keep going. Oh, one second. Okay, so again, negative times this quantity. Please be very, very careful. You'll have to distribute that minus sign through the parentheses. So that's going to give me 2w plus 24 minus 4w minus 16 all over 8w minus 4. Okay, combine like terms. 2w minus 4w is going to be minus 2w. Positive 24 minus 16. Positive 24 minus 16 should leave me with 8. All over 8w minus 4. Okay, but check this out. Now, and here's the reason why, right? I know that we use the LCM to get my least common denominator, but you got to be careful with polynomials because you may still wind up with a GCF due to the fact that I was subtracting a quantity. Here's what happened. 2, 8, and 8 all have a GCF of 2. There's actually a little bit more than that, but we'll start with that. So I pull out a 2, and that's going to leave me with minus w plus 4 all over 8w minus 4. Okay, but now we've seen this before in the previous section. Please look, these are really close. I have a negative w plus 4. Here I have a w minus 4. Those are the exact same term. It's just the variables and the different signs, right? And so all I need to do is pull a negative out of the top, and you'll have w minus 4 on the top, w minus 4 on the bottom. It'll all drop out. Really, really awesome stuff. So here we go. We have negative 2. If I pull out that negative, it's now a positive w and a minus 4. All over 8w minus 4. Those cancel, top and bottom. Again, the reason I wound up with a GCF, even though I used the LCM, the reason I wound up with a GCF is because the original problem had a GCF in it. I just couldn't see the GCF because I was subtracting those polynomials, and I actually had to do the subtraction and get it down to this simplified form before I recognized, hey, there is a GCF that was already there that I now have to pull out. So anyway, those cancel. Negative 2 and 8 leaves you with a negative 1/4. All right, now, will these always simplify down to just a numerical answer? Absolutely not. Absolutely not. You will not always wind up with a GCF that comes out even though you use the LCM. This example problem, you just happened to because the original problem had a GCF already in it, but it didn't show up until I had started to simplify and I was able to get rid of that GCF that was actually already there. So I just wanted to show you this example problem for a couple of reasons. First, you may wind up with a GCF that you'll find as you begin to simplify that you can get rid of. And you could wind up with just a numerical answer left over. It absolutely could happen, but again, it doesn't have to. It depends on the problem. That's why I do several example problems. So, here's another one. So again, I need to find the LCM in order to add these guys. I'm going to do the LCM because hopefully it'll mean that I don't have to simplify any. Although, you may still wind up needing to simplify if this guy already has a GCF in it that just hasn't. We just can't see it right now because there's some simplifying that needs to be done. So anyway, here we go. LCM. Let's see here. 6x minus 18 will factor. I can pull out the 6. That'll leave me with x minus 3. 2x minus 6. I can pull out the 2. And it'll leave me with an x minus 3. Which means that my LCM will simply be 6 times 2, which is 12x minus 3. All right, great. Here we go. First, rewrite it. So x plus 6 over, well, that factors into a 6, x minus 3. I need it to be a 12x minus 3. So I'll multiply top and bottom by 2. Okay, plus x minus 6 over 2x minus 3. I need it to be a 12. So multiply top and bottom by 6 and 6. Now, here's what I know. We saw this before. Because I only need to multiply the top and bottom by constants, what that means is the original problem already has a GCF in it. That GCF is the x minus 3. Again, this is another problem where it's going to wind up, after I add these fractions together, I'm going to wind up with that GCF of x minus 3 that'll cancel top and bottom. I just can't see it because of the way the problem's written. It won't show up till I start to simplify. So if you ever do one of these, and all you have, right, you have polynomials, but you only need to multiply the fractions by constants, it's because the GCF is already there. When you do these problems, and you will have to multiply top and bottom, which we'll see in another example problem, by one of those other factors that has a variable in it, it won't already have a GCF in there. So here we go. Let's keep going. We know though that this one's going to be very, very similar to the one that we just did. There's a GCF already in there. Distribute. So I wind up with 2x plus 12 all over 12x minus 3 plus distribute 6x minus 36 all over 12x minus 3. I have my common denominator. So I have 2x plus 12 plus 6x minus 36 all over 12x minus 3. Combine like terms in the top. 2x and 6x is 8x. Positive 12, negative 36 should give me a minus 24. And like I said, right, because I only had to multiply the top and bottom by constants, I knew I was going to wind up with a GCF that wound up showing up when I begin to factor. And here it is. I can pull an 8 out of all of those, and I'll be left with an x minus 3 in the top. That GCF was already built into the original problem. It just didn't sort of show up until I started simplifying. But now I can see it. I pull out that 8. It leaves me, sorry, that parenthesis got weird. Leaves me with an x minus 3 in the top, all over 12, x minus 3. So here we go. Cancel, cancel. The 8 and the 12 will simplify as well to a 2 and a 3, and we're left with 2/3 as our simplified form. So again, another example problem where there was actually a built-in GCF in the original problem that wound up sort of showing up for us when we started to simplify. We factored it out, and I wind up with a numerical answer. Head on over to the next page of the notes. We'll try another one of these where that isn't the case. We will need to multiply in order to get our LCM by some quantity that has a variable in it, and what you'll see is that all of this stuff doesn't wind up going away. You'll get a little bit more complicated looking answer. So head on over to the next page of the notes, and I'll meet you guys there.